Chapter 22 and 23, The Planets and Their Observers. In Chapter 21, we learned about some of the astronomers and their discoveries that they made using their eyes and their telescopes. Today we're going to learn more about those discoveries, what they actually were, how they observed them, and we'll also take into account some other observers, not human beings, but our spacecraft and our different satellites that are now out in outer space, being able to bring a lot of information back to our planet. A lot of these pictures you'll see are from either the book or NASA's website. If you go to NASA's website, they might have updated it since I last got these pictures, and they have some great information and wonderful pictures on that website. When we think about observing outer space, we think about often at first what our eyes can see. When we looked at the electromagnetic spectrum in previous chapters, we noted that the visible spectrum, the radiation that we see coming in from outer space, mainly sourced from the sun, is a very small portion of the possible radiation that could be coming in or existing. Here is the picture of the electromagnetic spectrum. Right here is all that we see with our own eyes. However, there's a lot more energy coming from other wavelengths that we can observe using different types of instruments. While we often only worry about infrared, visible, and ultraviolet radiation coming in from the sun, there are other sources of radiation that come from other entities out in outer space. We know that radio waves can be experienced through our radio speakers. They come from radio stations. However, radio energy, waves that are moving at that wavelength, can also come from elements in outer space, and we can observe them using a telescope that captures those types of wavelengths. X-rays and gamma rays, we'll also see, are important in entities that are kind of invisible to us and very mysterious, such as black holes. While we're on Earth, we normally can use just our human eye, telescopes, or radio telescopes. The first type of telescopes are ones that will be able to observe visible light. The second one observes radio energy. But then, we also have problems once we're inside our atmosphere. A lot of the atmospheric components, such as clouds and water vapor, will scatter energy and make it hard to see or hard to retrieve these wavelengths coming from outer space. One way to get around that is to go outside of our atmosphere. We can use balloons or rockets, satellites, orbiting observatories, or spacecraft to observe what's in our outer space by being in outer space. All of these together, sometimes spacecraft and orbiting observatories, are kind of linked together, so I'll use some of these words interchangeably. Another thing to note is that satellites, we have two terms of satellites. We have natural satellites, things that orbit our planet, such as the moon. Other planets have other natural satellites, such as rings and particles and moons. And then also satellites can be given to terms such as the instruments we use to collect the information from outer space. First is looking at optical telescopes. These are the telescopes that collect visible light, that small part of the spectrum that our eyes can see. Basically, optical telescopes are just magnifying the light so our eyes can see a further distance away. Often we have mirrors that are able to gather the light and reflect them back so that we can see this magnified vision. We have two types of known telescopes. One's a refracting telescope, which bends light, and the other one is a reflecting telescope. This is the one that uses mirrors and actually gathers the light and bounces it around and then sends it to your eye. The reflecting telescope was developed by Isaac Newton. The other type of telescope is a radio telescope. This retrieves radiation that travels from far distances from outer space. These waves are very large. They're big waves. So the mesh in a radio telescope can be larger and still capture the waves. It helps us to capture the information from really far away objects. However, since the mesh has to be big, so does the telescope. And you can see here the size of this telescope in West Virginia. It's steerable, meaning that they can turn it and face different directions in our atmosphere if they need to look at a certain part of our sky. So we're going to just go through our solar system today. And the overview of the solar system is the center of it is the sun. And we have our 8 planets that orbit around the sun with their satellites. So the satellites that orbit around each of the planets, such as our moon. Then we have the asteroids, which are mainly located in the asteroid belt. Our comets and meteoroids that come in and out of the solar system depending on how they're traveling. Outside of our solar system, we have a ring called the Kuiper Belt. So let's start off with our star, our sun. Really, it's just an average star. It's in the middle of its lifespan. Its only really important aspect in terms of us is that it's so close to us. Otherwise, it's just like any other star out there. There's millions of them. But being that it's close to us, it's the source of our energy, our light, and our heat. There are 4 parts of the sun that it's broken down into. However, the boundaries are kind of fuzzy. So you have the solar interior, the inside of the sun. Then the photosphere. This is the layer of light. Next you have chromospheres, which are this thin layer which has these rays or these spicules. They kind of look like spines, or the picture that, if you ever drew a sun as a kid, the picture of the rays that you would draw off of it. And then the outermost portion is the corona. You can see on the right, this is a picture of the sun experiencing what's called a solar prominence. It's like a solar flare that beams off of the sun and provides a lot of heat and energy being released from the sun. While we do know a good deal about the sun, we can't possibly land anything on its surface to collect information. So we only know stuff from remote observations. We're going to talk about the different planets. And in order to talk about them, I'm going to go through different missions in space for the different observers. These can be satellites, orbiting observations, or spacecrafts. First one I want to talk about is Mariner 10. This was launched in 1963, and it did 3 flybys of Mercury. And then in 1974, it also flew by Venus on its way to Mercury. And so we got information about those 2 planets, our 2 inferior planets that are between the Earth and the Sun. These are some of the images that the Mariner 10 got from Mercury. You can see that the surface of Mercury looks very similar to something else we might be familiar with, our moon. Surface of Mercury is embedded with tons of craters. One of the reasons for this is that it doesn't have an atmosphere. It's so hot near Mercury that the atmosphere has been burned off, and so lack of atmosphere allows those comets and meteoroids to make it to the surface and cause large impacts. The next observer is the Magellan spacecraft. This was an unmanned spacecraft deployed from the Atlantis spacecraft. So it went up into outer space attached to another spacecraft, and then it was deployed from there. This was sent up in 1989, and it took 15 months for it to get to Venus, more than a year. It then entered the orbit of Venus on August 10th, 1990. Venus has a very thick atmosphere, one of the thickest atmospheres ever seen. It is so hot on Venus that it's said to be like sticking your head in an oven and turning on the self-cleaner. The precipitation on Venus can be like acid rain. It's so thick and it's so hot and it can burn you. Venus is known as Earth's sister planet, but it's not really similar in very many ways. It's similar in size and density, and that's about it. In order to look at the surface of Venus, we couldn't just take images because this atmosphere would scatter back the radiation. So Magellan used what's called a high-resolution synthetic aperture radar. Radars basically radio waves that are beamed through into into whatever you're observing. They use radar in order to track how fast people are going in their cars and to hand out parking or speeding tickets. But in this case, the radar was used to penetrate through the atmosphere and be able to send back information about the surface of Venus. You can see here there are many formations on Venus. It looks like almost a movement. It looks like there's erosion. There are all these features, all these craters on there, but not nearly as many as what you see on Mercury. Here are some more features on Venus. You can see this one on the bottom here. You can see the shadow. This they call the tick. Looks very much like a tick. And they also found, besides these craters, they found shield volcanoes. Shield volcanoes are a slow-moving volcanic system. And they found that the plates, or what we have on our planet as the layers of the crust move around on the Earth's surface, they found similar concepts, similar aspects on Venus. So they found tectonic deformation, so movement of the plate systems on Venus. Another spacecraft is Galileo, deployed from Atlantis in October 18, 1989. This spacecraft took 6 years to make it to Jupiter. On its way out to Jupiter, it also saw Venus, which you can see in this picture has much more thick atmosphere with the imaging that was used. It took images of Earth probably on its way out just to make sure everything was working. And it got images of our moon. And once it got to Jupiter, it was able to observe a lot about this planet. We were able to see the dark side of Europa's moon, which we can never see because it's not facing us. So by having a spacecraft out that can look on the opposite direction that the Earth's view is from, you can see different features of outer space elements that you can't see from the perspective of the Earth, no matter how good of equipment you have. It also observed lightning on Jupiter. It observed lightning near what's called its large red spot, or its big red spot, which is predicted to be a 300-year-old storm. Next, the Viking went out on a mission to Mars in 1980. Mars is one of our most, observed and viewed planets because it's closest to us, and we're always curious about it. They found that Mars no longer had tectonic activity, so the plates on Mars did not move around. Viking was able to figure this out by using seismographs, the same information that we use to calculate earthquake waves and look at how intense an earthquake is. If one did occur on Mars, it would actually be called a Marsquake. In the mission to Mars in the 1980s, they sent down a rover and it could observe the surface of Mars. To me, these pictures just look like they're in the Arizona desert or the Australian desert. It's amazing how much it looks like you're just on Earth if you just saw this picture in a quick glance. But it's not. These are pictures straight from Mars. They also saw Olympus Mons, which is one of the largest volcanoes. And down the bottom, they took a picture of the South Pole, in which they are hoping to find liquid water. Again, more discoveries about Mars. The Mars Pathfinder in 1997 sent what's called a wheeled companion down to the surface of Mars. It's called the Sojourner rover. This rover took images, and it also was able to do chemical analysis on the rocks. Curiosity is the new spacecraft that is about to land on Mars. It's on its mission there now, and it's basically an amped up version of the Sojourner rover with a lot more equipment on it. Next we have the Voyagers. We have Voyager 1 and Voyager 2. They went out further. They went to Jupiter and Saturn, Uranus and Neptune. This all occurred in 1977, and you can see the pictures of the spacecraft being lifted off, and then the other orbiting observatories that are attached to it. Voyager got to see a lot of images of Jupiter and the big red, the red spot, the 300-year-old hurricane. It also got to observe the rings of Jupiter. And Jupiter has rings, but it's very hard to see them for us because of the way that the sun reflects off of Jupiter. Jupiter also has over 60 moons. You can see in this image down in the bottom left these two things. They look like little pimples, but they're actually the moons, Io and Europa. And you have two different ones. Io is a very explosive moon. It's pretty much like the hottest feature in our solar system. Not really our hottest because we have the sun, but it's a very hot moon. It's very explosive, has a lot of volcanoes and a lot of activity on it. On the other hand, Europa is a moon of Jupiter that is frozen. What you see on that right picture of Europa is actually the ice that's cracking. It's basically very cold. So these are two ends of the spectrum, very hot to very cold. Voyager also took images of Saturn and looked at Saturn's rings and Saturn's moons. It's very hard to always see Saturn's rings because you get basically a shadow from the planet, so it's hard to see the whole entire ring. But you can see in that picture in the middle there just how obvious this circle of illumination is around Saturn and the shadow from the Saturn on the rings because it's blocking out the sun there. So you can also see here some more features. There are more moons of Saturn. Saturn has a moon with a big crater on it, which could be from an impact. Then Voyager left and it went to the Uranian system in 1986. It was able to observe 5 large moons of Uranus that all have varied terrains, so they all differ in what their landscape looks like. Uranus is considered a blue planet because of the methane gas that's released and causes this blue color to appear. And then in 1989 it approached Neptune. This was a 12-year journey. 12 years to get all the way out to Neptune. On Neptune it saw a great dark spot, which also is probably a hurricane. And it took 3 billion miles for the Voyager to get to Neptune. Neptune was also blue due to the methane gases being released, but we know very little about Neptune due to the fact that it's so far away and we don't have very good information about it. Neptune also has rings and also has moons. Triton is one of the captured moons of Neptune. It's captured in its orbit. It wasn't naturally there. Maybe it was an asteroid or a comet that came close enough and then got sucked into its orbit. And you can see the rings. Neptune's rings are often hard to see because of the brightness of the planet, but in the picture, in the middle here, you can see those rings of Neptune. And again here you see the circle of illumination lit up by the sun on both Neptune and one of its moons. It gives it that crescent shape. Besides those observers, NASA also has 4 that it terms their great observers. And these are satellites that are outside of the Earth's atmosphere. Again, they don't have to deal with the interference of our atmosphere, our water vapor, our clouds, all the things that could scatter energy and make it harder to observe outer space. Hubble was set up in 1990, and it had an optical reflecting telescope and also UV light that it could observe. We're going to learn a little bit more about Hubble in a moment. The other 3, the Compton Gamma Ray Observer in 1991, obviously had equipment to observe gamma rays. Chandra X-ray Observer had equipment to observe X-rays radiation, and that helped it to measure black holes and also see the age of the universe, which they predict is about 12 to 14 billion years old. And last is the Spitzer Space Telescope, and this was able to retrieve infrared radiation, basically heat radiation. So they all look at different types of radiation on that electromagnetic spectrum, and put together we can get a good idea of what's going on in in outer space. However, there's still many questions left. So here's the Hubble, lifted off in April 1990, and it was on the spacecraft Discovery. It's actually very small. You see replicas of it. It's not big at all. And Hubble was able to observe a lot of things. It saw Pluto. It saw pictures of the comet called Shoemaker-Levy 9. It also observed Jupiter. But it supported what's called the nebular hypothesis. And it supported this by observing shaped disks of dust around young stars. Nebular meaning star. It also observed black holes. It observed further back in time than we've ever been able to see. One very unique aspect of Hubble is that it took what's called the ultra deep field image. Basically, Hubble stared at what to us visibly would look like an empty sky for 1 million seconds. It's kind of like taking an image of a street, and if you kept it open for so many hours, you would see all the cars moving by. You may have seen pictures like that where you see all the lights and all the cars and all this blurriness. Well, that's what the ultra deep field did, and it was able to capture radiation from things that we can't see, and it was able to see galaxies and what might be black holes. Scientists are still investigating what Hubble found in the ultra deep field. And we'll do the ultra deep field in our lab, so I'm not going to talk too much more about it. Besides the planets in our atmosphere, we have what are called minor members. These are the asteroids, the meteoroids, and the comets. And asteroids are these rocks that are orbiting between Mars and Jupiter. There's a long distance between Mars and Jupiter that's not found anywhere else in between the planets on that scale. It's that's where most of them are orbiting. Of course, some of them can get out of orbit. But they once thought that maybe there should have been a planet there, but scientists now think that that's not it, that even if you added up all the mass of the asteroids, it probably wouldn't make up enough mass to make a planet. So at one point they thought the asteroids were a broken apart planet, but now they kind of think it's just the asteroids. They can't, they never came together due to the gravity of Jupiter. One of the largest asteroid is called Ceres, but this is also known as a dwarf planet. As we discover more and more things about our outer space, we learn more about the elements we're looking at. Just as things can change on Earth, categories and classifications change in outer space also. Pluto once was a planet, but now it's considered a dwarf planet, because now that they learned more about Pluto, if they counted Pluto as a planet, we would have to have a numerous number of items also be classified as a planet. So instead, they've created a new classification called a dwarf planet, which Ceres is part of. Dwarf planets don't have to have cleared their orbit. They can share their orbit with other entities in the atmosphere or in the solar system. You can see obviously there's a lot of asteroids in the asteroid belt, so Ceres exists along with a lot of other particles out there. Another one is comets. Comets, the most famous one that most people know is Halley's Comet, which we talked about in the trivia section, that it comes around every 76 years, and it was observed by the Chinese for over 100 years. Or it was observed by the Chinese for over 10,000 years. Comets are actually large, dirty snowballs, and they're basically frozen snowballs. What happens is when they get near the sun, they start to vaporize. So the comet's tail is not always in the direction that it is headed from, but it's always closest to the sun. So in this picture here, this is the head of the comet, and the sun is somewhere over here. This picture here, the sun is always over here. Does not necessarily mean the comet's moving in the direction of the northeast here, but it's just that the sun is over here. We also have what are called meteoroids, and these are what are improperly termed as shooting stars in our night sky. It's not really stars that are moving around, it's these smaller particles, less than 1,000 meters, called meteoroids. And they have different names depending on where they are within the outer space or in our atmosphere. So meteoroids are what exists in outer space. Once they hit Earth's atmosphere, we call them meteors. Then when we have a lot of them happening, we call it a meteor shower. If they're actually found on the Earth, they're called meteorites. Don't worry too much about the difference between all of these. Just understand that they are particles that are falling to Earth. Many of them don't make it to our surface because the atmosphere burns them up. As I already mentioned, we have a new class of planets in order to take into account new information that we have found out about entities in our universe. So, dwarf planets, they still orbit our sun, but they're not the only objects in their area of space or in their orbit. They can be located outside of Neptune in what's called the Kuiper Belt. This is a band of icy objects that are found past Neptune, sometimes called trans-Neptunian Neptunian objects, TNOs. Pluto, one of the most famous ones, which was discovered as a planet in 1930 and now is one of our first dwarf planets, was thought to be a planet due to its position in our solar system. But later on, the moon Charon was discovered in 1978. Charon and Pluto kind of orbit each other. Rather than it actually being a moon, they almost have a binary orbit where they're both orbiting around a center of gravity. So in this way, Pluto cannot be said to have gotten rid of all the objects in its orbit. Charon does not act like a satellite to Pluto, but instead they coexist. And so that's one of the main reasons that it got changed. I won't say the word demoted, but it got changed to a dwarf planet. When the dwarf planets are outside the distance of Neptune, we call them Plutoids. Anything inside, such as Ceres, the asteroid, are just called dwarf planets. And that's the end of chapter 21 and 22.